it works this time. So the recording, I believe, was not accessible to anyone, right? For the first class.
No, sir, it was actually. I could access it through files.
Okay, so how did you do it? So you had to go to,
I
or you
opened
were
it.
accessing it through files, huh, on your Mac. Okay. What about SharePoint? Did anyone try via SharePoint?
I actually also copied the link and pasted it into Chrome. That also worked.
Okay. All right. So for whatever reason, it is not working for me. I know. So what's the percentage? Others, was it working?
Yes, sir, it
No,
was.
sir, it was not working.
Okay. And what was the error message you were seeing?
Uh, Sir, file is incomplete. File is
Okay.
incomplete.
Okay. So for the person for whom it worked, I mean, anyways, that lecture recording I have shared from the previous year. Who said it worked for them?
I did, sir, Prasad.
Okay, so Prasad, maybe if you can just download it and then share the link with me, and then I will share the link with the entire class.
Yes, sir, sure, sir.
Okay,
So it
thank you.
worked for me as well. I mean, I
Yeah,
think.
okay. So yeah, maybe one of you, Prasad, can share that link, and then I will share it with others, and hopefully that will work. Okay. So this is whatever kind of schedule I'm telling you. It is valid till we are in the online mode. Okay, for this semester. Okay. So the lectures mostly would be put under flipped lectures tab on Impartus. Okay, I'll be uploading 2 lectures per week, and the reason I'm uploading 2 lectures per week is so that you can be regular. So it's very important that you follow the schedule of 2 lectures per week. Okay. So that will be very important so that you can be regular, because in between we are going to have tutorials which are live, discussion sessions which are live, and if you're not gone through the lectures, those would be kind of very difficult to follow. Okay, and it will be difficult at my end also to deliver or discuss. Okay, so please make sure you go through these lectures as and when they are uploaded. Okay, as per your schedule, 2 per week. And mostly the way we'll be doing is, if I'm uploading lectures this week, discussion and tutorial on these lectures would be the week after. So at any point in the current week, you view the lectures, that will be okay. Okay. In addition, the lecture notes will be available on the class notebook. Okay. So you just have to go to 2102 CLL 121, and within the class notebook in the content library, I have made 2 section groups. One I have labeled lectures, other I have labeled tutorials. Okay. A tutorial is something which we need to decide. So do we have some conformity on that? What are the 2 slots? Let's say on Tuesday, which 2 slots can be used? There are 4 volunteers. I don't know if they are here or not right now.
So in most of the courses it was told open-ended. Though I'm not the volunteer, but it was kept open-ended. Like the profs were like whatever time suits for everyone. So from nowhere we got any confirmation. So it was like
So we can decide at our end. Only thing I think I will need to do is, it should not clash with the scheduled time for another tutorial. Even if the faculty has not fixed the time yet, but if we are fixing a time, it should not clash with tutorial time of another course. So that's the only requirement. So Tuesday, for let's say group 1 and 3, 3 to 4 p.m. Does it work for everyone?
Works so.
I mean, and when I'm saying works, that means there is, even as per your timetable, there is no scheduled tutorial or laboratory at that time. Okay. So I will email also, and then I will give time till end of day tomorrow, or maybe Monday, in case there is new information. So for now, 3 to 4 p.m. on Tuesdays for group 1 and 3. And then group 2 and 4, 4 to 5 p.m. Any clash?
No, sir, as the time is not decided for the practicals.
Yes, sir, it clashes with
Say it. Someone was saying.
sir, it clashed with my timetable with practical 302.
Okay. And 302 is a core course for everyone in this
No,
semester, or you just doing it this semester?
sir, it's a core course.
For everyone.
Mm, for
No,
my
sir.
I know it's a core course, but are you doing it in the normal? The reason I'm asking is if you are the only one who's getting affected, you can come on the prior slot with
no,
group
sir,
1 and 3
there are other students who are also affected by this.
at this timing. Okay. And what about 2 to 3 p.m.?
Sir, I'm free.
2 to 3 p.m. it will not clash with the 302 practical?
Yes, sir.
No, it will or it will not?
It will not.
So then group 2 and 4 p.m.
Okay, sir.
Sir,
1
actually,
and 3.
that
Yeah.
would be better that you give us a time so that we can decide. Maybe till Monday, we can discuss among ourselves and decide a timetable for us.
Yes, but the only condition would be, if
The
we
same day,
can be
right?
decided by tomorrow, okay? Because if some faculty gives alternate time which is not in the timetable, then again it will affect this. So
Okay.
therefore, all I'm asking is, yes, discuss. But since no one else has taken these slots, so just ensure that there are no regular classes scheduled in this time slots.
Okay, sir.
That's the only requirement.
So 2 to 3 was like suggested for Tuesday or Monday.
Tuesdays, I'm saying.
Okay.
Okay, so three to 4 p.m. right? For group 1 and 3 on Tuesdays, and 2 to 3 p.m. for group 2 and 4. Okay. So even though I'm saying end of day Monday, but ASAP there is any clash, let me know. Okay. So that we can actually have our tutorial on whatever schedule we are fixing next week. All right. Textbook I have mentioned here, 6th edition. The only reason, as I discussed in the previous lecture also, is that the problem numbers will be based on 6th edition, but you can use any edition from 4th to 7th. Okay. These topics you can look at your own. I have broadly divided it textbook chapter wise. I've mentioned the words for each topic, okay, and the number of hours. It will be somewhat tentative, but mostly we'll be following this. But yeah, it could be plus minus 0.5 or plus minus 1 in each part. All right. So total contact hours 42. Okay. I have mentioned some reference books. So if you can get hold of those for some of the topics, in the sense that if you want to get additional understanding, so chapter 1 and 2 of Chandler. So even though the book says statistical mechanics, but first two chapters are what we are discussing, which is classical thermodynamics. Okay, so this part has been discussed in one of the lectures, online material. Okay, that you can study thermodynamics either at particle level. So you say that a glass of water is made up of millions and billions or whatever number of molecules. Actually, we need to talk in terms of Avogadro number, so moles. Okay, or you can talk about as being at 25 degrees Celsius. Approximations, the two, one which is looking at water as a collection of molecules, Another which is saying, okay, I only know two things about this glass of water, its pressure and temperature. Both would lead to same answers. Okay, so statistical mechanics approaches the things from the viewpoint of collection of molecules. That is why we are calling it as statistical. Okay, it looks at statistics of molecules, their motion, their energies, their positions. In classical thermodynamics, we are only specifying a very few degrees of freedom, pressure, temperature, composition, and under some circumstances, which we call as equilibrium, both approaches lead to same answers. So chapter 1 and 2 of this book actually discuss classical thermodynamics, salt, you can say iota of information about molecular statistical aspects. So it's good reading. You can read on your leisure. Okay, and this other book is also good for alternate reading. In terms of, sorry, okay, evaluation, we will have total 4 components: minor, major, quiz, and coding project. Again, quiz and major depends whether you are on campus or not on campus at that time. Accordingly, the format will change. The minor exam would be online as per the current calendar. So that I would be taking via the Moodle quiz. Okay. So the minor exam, I am fixing the format. It will be a numerical based exam on Moodle. Major and quiz, the details as it evolves. Okay. Coding project, I will share the problem statement sometime in the middle of the course. Okay, because that's when we will be discussing the content related to this coding assignment. Okay. For audit, again, this can change as per institute. For now, D grade would be 30%, audit would be at 37%. There is no attendance policy, but as I mentioned, it is very important that you stay regular. So at least whatever live classes are being held, come to those. And then automatically, if you're coming to live classes, you would go through the shared material on Moodle. So please stay very regular. There is no reason not to. That actually applies to all the courses, not just this course. So any queries, any questions on this aspect before we move forward?
How many quizzes will be conducted?
Sorry, your voice was a little muffled. Can you speak slowly, please?
Sir, how many quizzes will be conducted?
Okay, so I believe no more questions. Okay, I hope my connection is still working, right?
Sir, the voice just cut in between and
Okay,
we
okay.
didn't
So there's
hear
problem
this.
with the connection. Okay. Yeah, so I was saying if there are any other queries or questions on the course plan, please feel free to ask.
So the number of quizzes that going to be taken.
There will be one quiz only. So think of this as kind of a substitute for minor 2.
Okay, sir.
Excuse me, sir.
Yes.
Sir, I checked with the slotting, and the 2 to 3 slot you kept for group 2 and 4 would clash with the decided time for MLL lab for 2020 entry. Like most of us.
Okay. All right. So that will also not work, right? And 4 to 5 is also not working.
4 to 5 might work for 2020 entry people.
How many students, if let's see how many are presently here. Okay, half maybe. Yeah, so the people who are here, for how many it is not working? 4 to 5 p.m. Group 2 and 4, 4 to 5 p.m.
Sir, for group 2 and 4, you can shift the time from 5 to 6, if possible.
that if so let us first see 4 to 5 p.m. for how many it is not working. It's easier for me if it's back to back. So 4 to 5 p.m. for how many it is not working, because I can shift, if there is a small number, I can shift them to the previous slot.
Sir, I guess all the 2019 batch have difficulty attending the tutes.
For either slot or only one of the slots?
Sir, for group 2. Because on
How
Tuesday,
many would be there from 2019 batch?
sir, I'm not sure of that.
Okay, so the 2019 batch can attend from with the group 1 and 3. Okay, so whatever is their number, they can attend group 1 and 3, that is 3 to 4 p.m. 3 to 4 p.m. will work, right? For the 2019 batch?
No, sir. The lab is from 3 to 5. So you can.
It's from 3 to 5. Okay, and group 1 and 3 will 2 to 3 p.m. also work?
Yes, sir.
Shift it upwards. And this 3 to 4 works for group 2 and 4, it was clashing.
Sir, works.
Someone mentioned, right? MLL lab for 2020 entry. What was the timing of that?
So the timing is from 2 to 4.
2 to 4, right? So it will clash then.
Yes.
Okay, what about Thursdays? If we shift it to Thursday, does it work? Okay, maybe so those volunteers or maybe new volunteers, focus on Thursday, 2 consecutive slots, anytime from 2 to 5 p.m.
Okay, sir.
Today you can just send me the options and then I will communicate it to the class. And by you mean at least I mean 4 people, from one from each group. Okay. So send me those and then I will communicate it to the class. Okay. So tentatively I am saying thoughts, but again this will be finalized only after I get input from the class. Okay. Yeah. So let's leave it for now, and we will come back to it. Any questions on this? Queries on this? Plan. Okay, so let's switch. So the class notebook 02 content library. So this course logistics I have put separately. Okay, besides that, you have lecture class tab and tutorial class tab. So in the lecture class tab, I will be putting the lecture notes. Okay, and in the tutorial class tab, I am putting the problem sheets, as well as I am putting the which contains the questions. Okay, so even if you right now you don't have access to the book, you might not be having access to library and all, so you can see the problem statements from here. Okay, and now I will first discuss briefly the design projects for the course, and then I will just take up a couple of tutorial problems. Okay. So project number 1 and 2, which is development of web servers, they are almost, I would say, complete. Maybe one more set of students. So this I have plotted for last 3 years. I think 3 years. Okay. So a lot of people have worked on these. So these essentially require whatever, let's say, work we have done in terms of predicting properties. In one case for silicate melts, which for example form the rock material. Okay, in the other case for determination of protein aggregation hotspots. So again, these details, if is interested, I will discuss with them. But main thing is that, and put that science as part of web server so others can use it more easily. Okay. And a group of students for past 3 years have worked on. So actually, I hope it will be complete now. Okay, so there's very few things left. So I'm certain that if there is a group of people involved, it will be complete this year. Okay, so that is part 1 and part 2. Project 3 also, almost 3 set of students have worked, and again project 3 has a potential for publication with some additional work, and of course there will be co-authors from previous years also. So project 3, again, read the problem statement. Details I will discuss once I get interest from a student, okay, or a team of students. Part 4 to 6 are more kind of easy design project credits. So on the flip side, they are easy, and on the other side, you really don't have any chances of publication or something in DP4 to DP6. Okay, but you just maybe are missing one DP credit. This will be an easy way to get a design project credit. Okay, so this DP4, which says refrigeration cycle thermodynamics, would kind of kick off around chapter 9, which is middle of the course. DP5 and 6, again, I mentioned the chapter numbers. DP5 will kick off on chapter 6, which is property calculation for pure species. And the 6th design project would kick off once we discuss chapter 10, which is vapor liquid equilibria for binary mixtures. Okay, for example, let's say water ethanol binary mixture. I want to understand at which point this mixture will go to the vapor phase. This design project 6 will try to solve that using computer programs. Okay, so this is the set of design projects. Besides this, while I am teaching, some idea comes to your mind based on content of the course, and you want to frame your design project around that, you are most welcome. Okay, so what I will do is I will share this where you can express your interest in any of the design projects. The way I allot the design project is first priority is to students who have less number of design project credits. Second, done using CGPA, so higher the CGPA priority. For design project 1 and 2, prior experience in some sort of web server design or something related would be a precondition. Okay, so broadly that's how I'm going to allot these projects. Any questions or queries on these?
Any sort of prerequisite for DP4 to DP6?
No. So all three are based on course content. There is no prereq for these.
Okay,
Even
sir.
DP3, DP3 to DP6, no prerequisite. Any other questions? Okay. So I hope the internet connection is okay. I'm audible.
Yes, sir.
Perfect. All right. So I will just solve a couple of easy tutorial problems. And again, in the tutorial, you will see most of the times, unless the problem is really difficult, I will not solve the problem from beginning to end. So I will initiate the problem in the tutorial, and then you will be expected to take it through. Okay. So problem 1.3 is essentially asking you to from one system to another system. Okay. This equation you will see later on, but I'll just briefly tell you. It is relating the saturation pressure. Saturation pressure means the pressure at vapor liquid equilibrium as a function of temperature. For a pure species, if I tell you the temperature, for example, let's say water, if I tell you temperature 100 degrees Celsius, you will tell me the saturation pressure is 1 bar. Okay, so that means there is a relationship between saturation pressure and temperature. The equation with small set of units, the equation with capital ABC is using another set of units. Okay, and they're asking you to convert from one to other. Look at how you will convert the logarithm. Start with any. So let's say I start with the natural log. This as z. And of course, you will have different, each person might have a different way of going about this thing. Okay. Now take the log to base 10 on both sides. And of course, z was ln x. So you have a relationship between natural log and the logarithm to base 10. Okay, so that is one part of it. Similarly, if you want to convert, so this part, be careful about. Pressure in kilopascal. So the way they're writing in book, they are putting sign the unit. It is not actually dividing by that. Okay, so they're just saying that this quantity has these units. So let's say I have a parameter p sat kilopascal. Find out the relationship between the same parameter if it is being defined in a different unit. Let's say torr. So easiest way to do that is on one side the relationship between kilopascal and torr. To be exact, it is 750.061. I'm just writing 750. Okay, so all I have made sure here is units are same on left and right. On left I have kilopascal, and now by putting vector on the right hand side, I have made sure the units are the right also. Okay, so if I have a parameter p sat in kilopascal, the same parameter p sat in torr on the right hand side needs to be multiplied by this factor of 100 by 750. Okay, to let's say take a simpler case. Let's say L is the length in meters, small l is the length in centimeters. Can you tell me the relationship between capital L and small l? Capital L is equal to what? So small l.
So this
100
capital L
times,
in meters.
Say it again.
So
100
this
times smaller.
Which number is smaller, capital L or small l?
Small L is smaller, no?
Think again. Capital L is the length in meters. L is the length in centimeters. Same length. Okay, we're talking about the same quantity.
Oh, then
It's either
Sir,
expressed in
otherwise
meters.
capital L is smaller.
Capital L is smaller, right? And how did we do this? You could have done in mind also. What I'm going to do is 100 centimeters in 1 meter. So from here I get the relationship. So essentially what you are seeing is that if you do it in kind of a stepwise manner, maybe it will take seconds extra. Chances of mistake would be lower. Here you could have written this directly also. And maybe 5% of you would have written it in the opposite fashion. For example, one person mentioned maybe that small l is a smaller number. Okay. So most of you, even without doing these steps, would have done it correctly. Making the error will change from one exam to another. Okay. So just be careful on these things. Question which I'm going to take up right now is 1.12. And again, I'm only taking those questions which directly do not require you have to see in the lecture in detail. Okay. So problem 1.12, again, you can see the problem statement at your leisure. I will just mention one aspect which is important here. So they have given you the differential equation. And here the problem of interest is how this pressure is changing height. Example of a particular city, Denver, which is sometimes called as the mile high city, because the is approximately 1 mile, as written here, above the sea level. Okay, and of course, because the authors are from United States, so therefore they're using Denver. Okay, if they were from India, they will use something else. If they are from Europe, they will use something else. Anyways, so this is the equation at hand. Find pressure as a function of height. We integrate. So say that okay. Pressure would be, is this correct? Yes, no, is it okay to write the integral like this?
Yes, sir.
It's only correct
Any
when
other
rho is constant.
if rho is constant, right? But if I read the rest of the problem statement, they are modeling the air column as an ideal gas. And for an ideal gas, I know the density would change with pressure. So presently, the equation I have has in fact two dependent variables, P and rho, one independent variable, Z. So I cannot integrate it. This equation, the ideal gas equation of state, eliminate the unrequired quantity, which is rho in this case. Okay. Now you will see there is a second assumption which they are taking. The atmosphere as an isothermal column at 10 degrees Celsius. So they are saying you can model the column as at constant temperature. Okay. At other times, more appropriate, model the air column as an adiabatic column. Temperature will vary, but you will model it as an adiabatic column. You will get one more relationship because you are saying now the system is adiabatic. Okay. So then you will not be able to take T constant, but you will have a relationship between P and T. So after eliminating rho, you need to eliminate T also. That you have an equation only in terms of P and Z. So one dependent and one independent variable. That's what you call as an ordinary differential equation. That ODE you will be able to solve by one of the methods you know. Okay. Last question for today, 1.15 or 1.16. Actually, they're similar or they're same exactly, except the units are different. Okay, in one they are using FPS system, in other they are using the SI system. Okay. So this is kind of a training also how to go about problem solving. So the first thing I will do for any problem, again you can read the problem statement. I will explain the problem statement via this diagram. When you start reading the problem statement, after reading it once, start making a schematic. What they have told us is gas contained in a piston cylinder. So a piston cylinder essentially means that you are attaching to your rigid vessel, and on top of that rigid vessel you have a movable cap. That cap can move up and down. The differential force acting on the this gas, which is my system, is exerting a force. Outside there is atmosphere. The force on the cap, depending on the force up or down, till the force is balanced. Okay. They are telling us that you have means of heating this gas. So you are heating this gas. That is one input they are giving us, and other input they are giving us is that the piston is movable. Okay. So first thing I need to do is we have learned what is the meaning of pressure. The definition of pressure.
The force per unit area.
Perpendicular area.
Sorry, perpendicular.
Right. So
Yes, sir.
I balance on the piston. My gas is at some pressure P. Equal force on the piston from the gas is PA, where A is the cross-sectional area of the piston. Cylindrical, the diameter is R, then the area would be pi R square. Okay.
Sir, your voice is breaking a lot in the middle.
Let me try switching connections. Sorry, I'm not seeing the other connection available now. Is it okay now?
Yes, sir, it's okay now, but sometimes it breaks in the middle.
I apologize for that. And maybe as and when the sound is not clear, you just let me know. Okay. All right. So this is the upward force. Now let us start counting the downward force. Can you try? What are the downward forces acting on this piston?
The mass of the piston and the mass kept on it, and the atmospheric force.
Let's say mg is the total, or m is the total mass, which includes the piston mass as well as any additional mass which has been kept on the piston. Okay. And the other thing you mentioned was? So let's say the surroundings pressure is known to me, P naught. Again, I multiply it by the cross-sectional area of the piston, P naught A. So from here, I can say that at equilibrium. So this is the part which I have not discussed yet directly. Okay. But you will see one part of the definition or requirement of equilibrium is mechanical equilibrium says balanced. Okay, that is the part of equilibrium definition we are taking here. And from here you can calculate P. So that is one of the parts which is being asked. What is the pressure of the gas? Part A is what is the force exerted on the gas by the atmosphere, the piston, and the weight. Plus P naught A. Okay, so mg plus P naught A gives you answer to part 1. The equation allows you to calculate the pressure, so this gives you answer to part B. The last part later, because you need to at least go through the second and third lectures. Okay, so you are being asked to now can do the work, but so far I have not shown you the expression for work. Okay, so this I will hold off on till the next. So that's all from my side for today. If there are any questions from the lecture content, any queries, please feel free to ask. If you're going through the material, even if you're not going through the material, if there are any questions, queries related to those lecture components, please ask.
Sir, when we have to do that mini project?
The design projects.
Yes, sir.
Yeah, so I explained. So first, I will be sharing a sheet on the collaboration space about the projects. Okay. Then, in principle, DP1 and DP2, you can start at any time. Okay. So whoever is allotted, because this is not related directly to the course content. Similarly, DP3 to an extent is not something which we discuss in this course. So the student is interested can start DP3 also at any point. The design project 4 is based on chapter 9 of the lecture content, refrigeration. So it will start only at that point, which will be sometime in the middle of the course. Okay. And then project 5 is based on chapter 6, which is, let's say, roughly at 1/3 of the course. And DP6 based on chapter 10, again in the second half of the course. Okay. So DP4 and DP6 will start sometime at the halfway, sometime at the 1/3 level. Essentially, you will know. Okay. So DP4, once I'm done with chapter 9 in the class, you would know whoever has been allotted, they will need to contact me and they will be able to start the project. Okay. Similarly, DP6, once we get to chapter 10 in the course, they would know they can start. Just email me and I will help with the initiation of the project. Okay.
Okay, sir.
So there one question in the lecture that how the work is precisely measured in the Joule's experiment. Yes, how the work is measured precisely in the Joule's experiment. This is the question.
Yeah, but what is your input on that?
Sir, I guess we check the height of the block that comes down and transfer the potential energy into the work done.
Yes. So if I can precisely measure the vertical distance the block is traveling, I will be able to precisely measure the work. And that's how he did it. Okay, today we might have, okay, but that's how Joule did it. By very accurately measuring the fall and rise of the block. Okay.
Yes, sir.
Other questions, queries?
Sir, any information about coding project?
I will share that. So again, that would be mostly based around refrigeration. So I'll share that at appropriate time.
So in the lecture, there was one point where you said that W by M is independent of absolute value of temperature. Could you just explain this once again? Were you talking about the value of specific heat that we'll get from this or anything else?
Say it again.
So that W by M is independent of absolute value of temperature.
Your voice is, maybe it's my internet connection. Please try to speak slowly and a little loud.
So W by M is independent of absolute value of temperature.
So again, referring to the Joule's experiment, right?
Let's say you are not audible.
Yeah.
Now you are audible, sir.
Now I'm audible, right? So you're referring again to the Joule's experiment, right? So this is the quantity you're referring to. So try to write it out. So the work done in Joule's experiment is getting converted to what we are calling as internal energy gain. So what is the internal energy gain? Am I still audible?
Yes, sir.
So if delta T is small, specific capacity is fairly independent of temperature over a small range of temperature. Okay, so from here you can see that the quantity W by M is not dependent on absolute temperature, but rather only dependent on temperature increment. And that was one of the observations of Joule. The work required per unit mass for 1 degree Celsius increase in temperature was fairly independent of temperature, absolute temperature value, that is. So was that part audible to all?
No, sir, your voice is fluctuating very much, coming and going.
Let's try. Is it okay right now?
Yes, sir.
Yeah. So the internal energy gain Cp delta T, assuming Cp to be a constant. The work done is W. In Joule's experiment, all of work done to internal energy gain. So therefore, W by M comes out to be Cp delta T. And that was one of the observations of Joule, that the work done per unit mass to increase the temperature by 1 degree Celsius was independent of T. That means independent of the actual temperature. Problems. So there's still issues in voice.
No, sir, you're audible.
Okay, so this point is, so that's what you were asking, right? That why W by M is independent of T.
Yes, sir. I understood, sir.
Okay, so that is understood now.
Yes, sir.
Okay. Any other queries, questions?
So there is an example given the lecture that said there are two chambers at T1 and T2 temperature and both are at thermal equilibrium. Then the question said that are they at mechanical equilibrium? So is the answer is yes?
What is your answer?
Yes, sir. Yes, they should be. They must be at mechanical equilibrium. Sir, because if the wall is fixed and temperature is same, the number of moles on this both side remain constant, so their pressure will be same.
So this is what we are asking here, right? The question
Yes.
about the pressure, right? So if T is same in the two, T1 is equal to T2. Is P1 also equal to P2? So this is only going to be case for a very specific scenario. And you just mentioned that very specific scenario. What is that specific scenario? When P1 will also be equal to P2?
So when the wall is fixed and the number of moles and the volume of both the sides are same.
And the species is also same.
Yes.
Right. So only if the composition is same, or it's a single species which is same on both sides. And as you suggested that I need the volume to be same, only then P1 will be equal to P2. But is it correct to say that they are in mechanical equilibrium? That is a very specific condition we are putting, right? Mechanical equilibrium needs mechanical contact. Let's take an easier example. Let's say this is non-conducting. So adiabatic partition and adiabatic vessels. Are these two chambers in thermal contact?
No, sir.
That's right. And if they are not in thermal contact, I cannot talk about thermal equilibrium. Similarly, the two chambers I've shown which are separated by a rigid boundary, they are not in mechanical contact. Okay, and therefore, in general, P1 will not be equal to P2. But of course, you can independently fix P1 and P2 on both sides and make it equal. But that would not mean they are in mechanical contact. So therefore, I cannot talk about mechanical equilibrium. However, if you separate the two chambers by a movable boundary, so I put a piston now. Now the two chambers are in mechanical contact. And now if I wait long enough, get mechanical equilibrium between the two chambers. Okay, so in short, to be in contact for us to talk about equilibrium. Okay, is that clear?
Yes, sir.
Other questions? Okay, so it's good you're going through the material. There's still some questions that I have marked for discussion in the lecture, but no one has asked them. So we wait for the next tutorial. Okay, temperature, specific capacity, that question, heat, no one has asked. Other one is the dead weight tester. Okay. So, and there might be some more which I'm missing. So please be regular and use the discussion session and the tutorial. Tutorial will be held every week. Session would be on need basis. Roughly, I explained 3 tons. Okay, but it will be on a need basis. If you require more, I will have more. If you require less, I will have less. Okay. Queries?
Sir, excuse me.
Yes.
Sir, in the course distribution, you mentioned a project also for, I think, 12%. Is it, it's different from the DP course, right?
Yes, yes. So the design credits are part of, they're not part of your regular course assessment. Okay, so they will contribute towards that DP, design practical experience units, your NGU unit. And the coding project, which is 12%, that is part of the course.
So, sir, will you be telling us about it like at some point?
Yes,
Because
yes. I mentioned that it will be based on, again, some part of refrigeration
oh, okay, right,
cycle.
right,
Okay,
sir.
so it will come up in the middle of the course.
Okay,
Coding
sir.
statement I will share in the middle of the course.
Right, sir. Thank you, sir.
Okay, any other questions? So then I will close the recording.